Okay, this is, as promised last week, we're looking at, I don't know if it's job number 3 or job number 4. It's the milling fundamentals with the 5 holes in it, 2 different size reams, and 1 threaded or tapped hole in the middle. I talked about last week the operation sheet, how you should go about it, so you should know what tools to use. You should write down your steps in that process plan like we talked about last week. So you should be able to do that so you can kind of think through your steps for machining this. All I'm going to do right now is show you how to pick up a corner and be able to move the machine over your holes exactly, and then we'll do the first operation on this one, which is, what's the first operation after we machine it to size? What would we need to do on this? Well, you guys got to have a plan before you come up and do this. Remember? Well, let's go through the tools. What kind of tools do we have to use for this? There are 2 half-inch reamed holes. So what kind of tools do we use to make 1 hole? Give me the steps for making 1 reamed hole, let's say. Oh, you ain't been watching the videos or anything, huh?
Start off with a little pilot drill.
You do a center drill, yes. So that would be the first step. So if it's a half-inch diameter hole that has to be reamed, that's the finish size. What's the drill size going to be for that? Once again, don't come out here until you know this, okay? Remember our rule? Leo, you remember it? Reaming, what size drill do we use for a half-inch reamed hole?
20,000 less.
Pardon me?
Is it 20,000 less?
15, 1/64th less on the average. 10,000ths is okay too. But, so you would take a half-inch minus 15,000ths and you would come up with 31/64 or something like that, right? That's about just under a half-inch. Now we do have a kit for this, but it's your responsibility to measure the drills and understand that not necessarily the correct tools are going to be in there. So then you're going to use a 31/64 diameter drill in the center hole in the 2 places. And you're going to come back with a half-inch reamer. What's the rules for running a reamer? How many RPM? 100 RPM. And what do you use in addition to a slow RPM? Cutting oil. All right, don't forget that. So now our next hole, there's 2 of them at 7/16, so 0.4375. So you will go down 1/32 or 1/15,000ths from there. That'll be your drill size, and you'll have a 7/16 reamer. Remember to measure the tools. And then we're going to come back with a tap drill for a 3/8/16 threaded hole. And there is a particular size. I think it's 5/16 in diameter, but where would you find out what kind of tap drill you're going to use for a 3/8/16? Where do you find that out? The chart on the wall. You locate your thread size and then the 75% thread, and there it will tell you. I think it's a 5/16, but don't quote me on it. All right, so first thing we got to do, I recommended everybody do a layout. You just need to lay out the scribe marks. You don't need to do the punches. It'll help you maybe look at it a little bit differently, but what we have is a datum in the lower left-hand or the lower right-hand corner of the part, right? So now what I'm going to tell you is that if you have a datum, you want the edge. So on right now the drawing, it's going to be this bottom edge here. You want that edge against the fixed jaw. So that means this part that you're machining is going to be flipped over upside down basically. And now you're looking at it with your datum in the upper right-hand corner, all right? So you literally take your drawing, and if that's your datum, you make sure this edge is against the solid jaw, and now this is your drawing that you're following. Yep, it's rotated around, but Always, always, always put your datum edges against the solid jaw, okay, the fixed jaw on the vise. There's reasons that you don't do it this way because, remember, there's tolerance here. So if you do this lower edge and that's against the floating jaw, these pieces will have tolerance variation, so you won't be able to maintain that tolerance if you're doing multiple pieces. If you're just doing one piece, it won't hurt. But just start off, even if it's one piece, follow the best practice and you'll never go wrong on other pieces or other jobs. So really what you need for this now is I'm going to take you to center drilling it, and we'll drill all 5 of those holes. But really what we're going to need is our parallels. Have yourself a caliper ready to go. You'll have the kit. You'll find that in one of those yellow bins. Here is something we use to locate our edge. This is called an edge finder. I'll show you how, that's what I'll be showing you how to use. And for my operations here, we're going to use a center drill, number 5. And then you find yourself a drill chuck. Okay? Was that somebody's phone or is my camera complaining? Okay. We know how to load a tool. Leo, you want to come up here and get this tool in here, please? And do you have a problem being on camera for this? Because we are being watched. Okay. I just want to make sure you don't have a problem with that. So get that out of the way. There we go. And then put our parallels in and just put the piece somewhere in there. So while he's doing that, we already said our piece is going to be upside down now, the datum edge against the solid jaw. And now we're going to do what's called picking up or locating the edge of the part. All right? We're going to use that tool. And the first thing you're going to need to know is that edge finders, you can tell you have an edge finder because you'll see the top of it. It's like swivels off center. Okay? And the way this thing works is when you are over an edge, it will straighten out, but then it will jump again sideways parallel to the edge that you are indicating. So what you need to know is the diameter of your tip. This one happens to be 0.2 exactly. We only have 2 flavors in the shop. One of them is 0.2 and one of them is 0.5, and those are the 2 that we have on loan. This is one, it's a really inexpensive tool. And okay, so we'll put the edge finder into our chuck. I'm going to lower down the table. Right about there is good. So now what I like to do, we have some magnets sitting around here. I usually kind of just pin up my drawing right there while I'm working on it, but also I don't want tools, you know, to be stored. This is a plastic tool, so it won't hurt. But I don't like having tools stored, or even lightweight measuring tools, on our tables. All right, because people tend to, you know, do something like that, and you know, all of a sudden you're getting little divots in your table. No good. This won't do it because it's just a plastic hammer. But that's why I've got some little rubber pad here, so I just kind of keep my tools on that. So we are now working on this thing. Our reference corner is up here. So now what we need to do is we need to get the center line of our spindle right over that edge. Okay? So the way we use this is we lock down, we come into gear, run this thing at about 500 RPM. Remember, don't shift the RPMs unless the spindle is running. Do not change RPMs or these motors won't work too well. So now you see we're spinning and this bottom is way off center. So the way you pick up an edge is you now position this behind the first edge. So we're going to indicate the datum for the y-axis. And on this it's okay if you want to advance the quill down a little bit. When you're milling, of course, we said we want that always to be up. So now it's just rather simple to come and say, all right, I'm going to start bringing the table. Remember, always take your slack out by going in the opposite direction and then going back. Always do that. And now we're going to just move this until we straighten that out. Now you'll see it's straight, right? It's now you give her a tap very lightly in the same direction. The minute that thing shifts, you're on the edge. But the edge of this is on there, not the center of the spindle. We're still 100 thousandths away, or half that diameter we measure, okay? So the way you now do this is you just kind of tap your way. Keep an eye on it because it's going to jump. Do you see how it now jumped offset? So let me zoom the camera in on that real quick while that's running, and then you can see now that the edge finder has jumped sideways. That means the edge of this little pilot, which is 200 thousandths in diameter, is right exactly on the edge of this. So now you turn off your machine. You either roll the quill back up, or in my case, I got to bring the table down because we don't want to do the next step with the part engaged. So what I need to do now is I need to go in that direction, half the distance of the bottom, and we'll be right over the center line. So if you want to, you can set your dial to 0 here, but you're going to need to reset it again. So right now we're 100 thousandths away, right? Because this is 200 thousandths in diameter, we need to move 100 thousandths. On our wheel, our graduations, our advancing the wheel is every full rotation is 200 thousandths, right? So that means I only need to move 100 thousandths. And what I'm going to do is go from 0 to 100 right there. Now look at the problem I have. What does this tell you? I'm far away from it. I went the wrong way. Okay? So that's okay. I can still recover. My setting hasn't changed. Instead of going in this direction, I go in that direction. So what we do is we go back to 0, and then we advance it to 100 thousandths. Okay, sorry, I went too far. Get back to 0. That was the edge right there, I think. Yep. So we're on the edge now, and now we go an extra 100 thousandths. And I usually just tap it and bring it home on the last couple. Right there. So now we are dead over the center. And by bringing down the piece, you can see by eye, we are halfway. So what we do now is we set our dial to 0. Because now the center of our spindle is right over the edge of that part in Y. Now we need to pick up the X. So I bring this back up. Bring the table over. I've already got my 0 here, and you'll know that anytime the center of a drill or something is sort of over the edge and it's 0, you know you're right there. So I'm not worried about this. I bring it over, advance it in, and I will do the same thing. Turn it on. You can just take your finger and just kind of tap it. And now I do the same thing. Advance the wheel until it gets even. But this time, because we're doing the X, the wheel is going to offset in this direction, parallel to our edge. So I'm just going to get it so that it's almost lined up perfectly. There we go. And the camera's still zoomed in. And now I'm just going to keep tapping it until it jumps sideways. There we go. Did you see it just now? So now our edge is sitting 100 thousandths. So if you want to do it conveniently, again, you set your 0. And you want to set it without moving your wheel, of course. And now we're going to move an extra 100 thousandths to make up for the radius of our indicator. And now we are, if you take a look, right over the center in X. So I'm going to set my 0 again. Now we've done what's called zeroed out our table. Now what some people do we have that black marker, Brad, that you were using? What some people do is they'll put a witness mark on the saddle and the table. So what I do is, and this is washable, so this will wash right off, but now you see I have a little witness mark there. So I know that when I move this, and I come back this way, when I'm over the 0 on this dial, when those are lined up, I know that's the right 0. So this way, you know you're lined up. And you can do the same thing on the Y, but it's a little more difficult. Okay, our 0s are set. So now, there you go. So now what we have is the machine datum set there. Both wheels are set to 0. So our first hole, now we just start, I'm going to zoom in on the hand wheel here, and then I'm going to zoom the camera back out again. So that was zoomed in, and we were looking at that. Now you can see my wheel here. For those of you who are going to watch this video, you can now see the wheel is set to 0 there. And I'm going to zoom this back out again. And now we'll just do the rest of the exercise right there. Okay, so will somebody take that tool out and please put the center drill back in. So take it by hand, get out that tool, put the center drill in. I like these hand turn chucks. You're going to find they're the best in the shop. They're truest, and I like to use these. And you got to kind of get it up there and then get it centered. There you go. Not quite. Okay, very good. Now, we're going to be using the quill. So of course you want this unlocked. You want your stopper all the way down, because we're going to be drilling like so. And now we want to make sure that our wrenches and stuff are out of the way. And I'm going to drop the table down just a little more. So the first thing we do is we got to understand what kind of RPM we want to use for the center drill. About 500 where it's at will work. So again, high to high. Make sure you're spinning in the right direction. If you're in high gear, you flip your knob to high gear and so on. This is your brake. Make sure you don't have it latched on so that we don't burn out our brake in there. Double check this one more time. Okay. So now our first hole, I'll make it this one, is a 1/2 inch in and a 1/2 inch down. So 0.500, right? So first thing I'll do is I'll move it there. I'll locate my y-axis, just make sure I'm in the right place for 0 because I didn't give myself a witness mark. But if you sort of just by eye move close to where the center appears to be, so you can see I'm pretty close. So that means the 0 that's right there is the right 0, okay? Because we set that all. So again, what I'm going to do is I'm going to go back it off, and now I'm going to bring it so that we're always advancing in the same direction, okay? Got to get the slop out of there. So I'll put this on the 0. Make sure we're lined up, and we are. So I'm now over 0. So now I got to go 500 thousandths. So there's 2, 4, and another 100. And now we're at a 1/2 inch down. Right? One full turn is 200. The second turn gives you 400. half of a turn gives you 100. Same thing now with the X. I got my witness mark sort of right here. So that means the 0, I'm now at 0. So I'm going to go 200, 400, and another 100. And now I'm right over that mark. These little knobs here will lock the axes. If you want to just snug them up, then the table won't move on you once you've got the position set. But look, I went the wrong way, didn't I? Wrong way. Okay, easy enough. Go this way till we're at 0 with our witness mark. And now I go 2, 4, an extra 100. And now I'm ½ inch in. And we can drill. Now if you have laid this out, we would see right away if that little brick mark is right over our intersection. If you just do the layout, that's why I recommend it. What I could also do is, I'll just open this to like 500 thousandths. Now this is not a precise measurement, but by simply holding it there, I can kind of see by eye that I'm ½ inch in and ½ inch over. Okay? So that's just a crude measurement, but it will kind of give you an idea. Best is if you kind of have it laid out already. And now you just kind of drill it. And what's the rule for depth of these things? 2/3 of the way up the angle, right? So now, the next hole is 2.375 all the way over. So that means I'm already at 0.5. We'll loosen that up. And now I'm at 0.6, 0.8, 1 inch, 1.2, 1.4, 1.6, 1.8, 2 inches, and now an additional 375. So here's 2 more, plus another 175. A little touch. Turn off your machine. We haven't changed this direction, but again, I just now make a 2.375 setting on my caliper, and there I am, right over the center of it. All right, again, this is not a precision measurement method. It just gives you a real quick, because if you're off on these, you're going to be off by 100 or 60, and you'll see it right away. If you've goofed up, bring it back to 0 and bring it back again. So here we now turn it on. We'll drill the next hole. 2/3 of the way up. And now I'm going to do the same thing in this direction. So the table's going to go that way. I'm already at 0.5. So there's 0.6, 8. So now we're at 1 inch. And I got to go 2.375 that way. So now I go 2, 4, 6, 8, 10. So coming up to the 0, and we'll be at 2 inches. And now another 375. So there's 2 plus 100 is 3 plus another 75. Do a touch. Have a quick look. Okay. Now we're good on that one. And the technique I'm using is peck drilling. Always go down a little and then back to drill out of the hole. The idea being we want to get all these little chips out of the hole. You don't want them to stay inside the drill. So now I got to go back to 0.5. But what we're going to do is we're going to back it all the way out to 0 and then come back in that direction because of the slop, right? So now I'm at 0 here. So now we're going to go in this direction some more. I've passed it. Now we're going to come back. So we're at 0. There's 2, 4, and 0.5. I'm going to touch it. But I can see that I'm in line with that one. And that's in line. Now we can just go and drill it. I went a little large on that one because this is just an estimate, and what this does is it now helps the drill find the center. So now what we need to do is just do the same thing here for the center. So I'm going to go back to 0 this way, back it up, and now go in that direction, and the dimension we want is 0.4375. So now we're sitting at the 0, should be. Yep, we're right over the edge. So there's 200, 400, 4, and then another 37 thousandths. So we're at 400, 10, 20, 30, 350, 375, 4375. There's 30, 43, and then 35, 375, and oh gosh, 1.4375. Sorry, let me take it back to 0. And we'll go 2, 4, 6, 8, 1 inch, 2, 4. So now we are at 1.4. And there we are. 1.4. That should be about in the middle, but it's not. I'm somehow off. I must have miscounted. Or am I? 1.6. Yeah, I went 200 thousandths too far. So let me back it out. So I'm at 6 instead of 2, so I'm going to go back to that 0, and now I'm going to advance it this way again. So there's 2, 4. I think I've lost track. That's about right. Wouldn't you think? In the middle, roughly. 1.4. So we're right in the middle. So there's 1.4. And then 37 thousandths. 35, 6, 7. So now we're okay in the X. And now I'm going to go to the same thing in the Y. We're now, this is at 0. So we're going to go 2, 4, 6, 8, 1 inch. And then another 2, 4. And now 37.5 thousandths. Right there. So let's put a little dot there. And again, if we did this with a layout, we would be able to real quickly see it. But I have the dot here, so now I go 14375. So we're right there. And we're good to go. I'm just doing this quickly, but should be all right here. And now you change tools and continue on. This is convenient because the next bunch of tools you're going to use are going to be drills and reamers, which you'll use this chuck for. So I'll leave this set up if anybody wants to kind of practice with this one, finish it up, or just go ahead and do your own. But that's it. So, any questions? In a little while, I'm going to have you use these. That makes life real easy, because instead of counting off increments on this dial, you'll just get a readout automatically. And it's important, though, that you know how to use these dials, because most manual machines will have some form of digital readouts. We have it on the lathe, but getting to know how to do it with the hand wheels is important, so that's why I practice it. All right? Okay, have fun, and I'll be around when you're ready. Remember, this is 875, not 9375, right? 2.875 long, 2.875 wide, and 0.875 thick. 5 holes. I don't know whose that is, but all right.